Hello everyone. I am Dr. Velamani P.S., Professor, Department of Computer Science, University of Science and Technology, Meghalaya. In this video, we are going to see the cloud computing concepts. The contents are introduction, layer infrastructure of cloud, types of cloud computing, the characteristics of clouds, and the quality of services, scalability, and elasticity, the system security, benefits of clouds and its applications. First, let us take the concept of computing. So, from the beginning, how the computing concepts started, let us have a look on this. First, computing, it was mainframe computing. The mainframe system connected with the terminal, and the user is used the terminal. The second one was personal computing. The personal PC was utilized to store the uh, data and process on it to get the desired output. Then, the moment the more number of systems will be connected in the shared environment, which is said to be network computing, a PC can be connected with another PC or another server, which can share the informations from the server or from PC to PC. Then the internet computing. So the networks of networks, the more number of systems in the world wide, which is connected with the server from the world wide web, the service, internet service providers, they will give the services to our personal computer by using ISP. So this internet computing is dealing with the large number of computational devices and its connections, the data retrieval from the server, and processing on the information, and sharing of the resources. Then grid computing. So the grid computing is the concept. The data it will be stored in the form of various grids, and these grids can be connected with each other, and the storage of large volume of data also that will be handled in this grid computing. Now the stage of cloud computing. The cloud computing, it is in the internet environment, the various grid level of connectivity is going to be connected with the PC. We'll see in depth definition of this cloud computing in our further slides. So these are all the from the initial stage of mainframe computing to the cloud computing level. So the cloud versus big data. So the big data, just I have mentioned as simple points over here. The big data is the huge volume of data generation and which will be distributed to the different system which can be analyzed for the solutions. So that is the big data. Then the cloud computing, which is going to provide computer resources and services plus networks to the data server. The service providers maintains this data in the server. So that is in the cloud computing. So with this focus, if we will give the definition, a main focus of cloud computing is provide computer resources and services with the help of network connection. While big data is about solving problem when huge amount of data get generating and processing. So in cloud computing, the data is stored in the server, which are maintained by different service providers. We can access the data with the help of internet. Whereas big data breaks large amount of data and distribute it across different systems and will be analyzed and processed. cloud computing. So cloud computing, it provides shared resources on the internet in scalable and simple way. And also it uses remote control servers and internet to maintain applications and data. So it is a computational computing technology that uses a remote control servers, remote area servers, and internet to maintain the various applications and different type of data. And it is a term which involves networking, virtualization, software, web services, and distributed computing. In cloud computing environment, there are various challenges like efficient load balancing, real benefits, business outcome, resource scheduling, data center energy consumption. So the efficient load balancing on the servers, that is also a kind of challenge, and the real benefits, the business outcome, which we need to take under consideration, or and also the resource scheduling, the various resource needs to be scheduled in the server side, the data center energy consumption. So the energy consumption is also the another fact, another challenge in this cloud computing environment. So the advantages of the cloud computing technology includes cost savings, high availability of the data, and easy scalability. Now the types of compute cloud computing. So based upon the deployment, it is private cloud. It is available for the private users, and the public cloud. It is a open cloud infrastructure for the public, and the hybrid for the industry levels. So deployment model, that is like this. Then the service based model, based on the service model, the infrastructure as a service, IaaS, the infrastructure as a service, cloud infrastructure. Then the platform as a service, PaaS. Then another one is software as a service. We'll study one by one in our further slides. Types of cloud computing. So let us have a look of this particular diagram, and we will exactly identify where exactly the types are coming in this. So number one is public cloud, number two is private cloud, number three is hybrid cloud. So three types of cloud environments are there. If we can see here the public cloud circle, the public cloud circle, that is here. Then the private cloud or internal cloud. So that is private internal, then the public external, that is also there. Then the hybrid, so it is going to combine the internal, private internal, and public external. So from this diagram, easily we can understand all these types of cloud computing concepts. So the user, so let us see the definitions, how it takes place. So the public cloud or external cloud, the public cloud or the external cloud, computing resources are dynamically provisioned over the internet via web applications. So internet via web applications or web services from an off-site third-party provider. So third-party service provider will provide the public cloud services. So the public cloud are run by third parties, and applications from different customers are likely to be mixed together on the cloud servers, storage systems, and networks. Example, Amazon and Google Cloud. Then the private cloud. So we can see here the private cloud. The private cloud refers to cloud computing on private networks. So the private cloud are built for the exclusive use of one client, specific client, a particular client, providing full control over the data, security, and quality of services. Private clouds can be built and managed by a company's own IT organization or by a cloud provider, example IBM, Oracle. A hybrid cloud environment combines multiple public and private clouds. So, multiple public and private clouds. Hybrid clouds introduce the complex complexity of determining how to distribute application across both public and private. So this is the hybrid environment. If you'll see in this figure, the public cloud environment is this. Inside this public environment, various public external will be connected with each other. A user will be connected to the public external environment. Then the private internal, again the user will be connected like this. The user can access the cloud services. Then the hybrid, the combination of this public external and the private internal, that is our hybrid cloud environment. So the types of cloud computing, a software as a service, that is for the customers, a product that is run and managed by the service provider. So don't worry about how the service is maintained, it just works and remains available. So that is the services will be provided for the customers. Then the platform as a service, this is for the developers. Platform as a service. It focuses on the deployment and management of your applications. The point is, don't worry about provisioning, configuration, or understanding the hardware or operating system. Just develop the services platform. Then IaaS, infrastructure as a service, the basic building blocks for infrastructure, the cloud IT. So the provides access to networking features about and data storage space. Don't worry about IT staff, data centers and hardware, that we will take care. So there are several applications and the several services for several developers that can be depicted in this particular diagram. Cloud computing layers. So the cloud computing layers, application, software as a service, then platform as a service, then infrastructure, IaaS, infrastructure as a service, then virtualization, then the servers and storage, the data storage as a service. So all this takes place in the layer level application SaaS, then the platform PaaS, then infrastructure LaaS, then the virtualization, servers and storage DSaaS. So like that manner, these cloud computing layer will takes place. So as we know that cloud computing usually include IT services referred as to SaaS, software as a service, which is shown in the top of the stack. So it allows user to run application remotely from the cloud. So infrastructure as a service refers computing resources as a service. So this include virtualized computer which guaranteed processing power and reserved bandwidth for storage and internet access. Then the platform as a service which includes the operating system and required services for the particular applications. Then the data storage as a service. So the it provides storage that the customer is used to, including maximum size of the data requirement for the storage. Then the stack to manage cloud services in the layers. The stack, what does it indicates? The stack indicates to manage cloud services in the layer. Characteristics. So if you look at the characteristics, on-demand service, broad network access, resource pooling, rapid elasticity. So on-demand service, what will happen? Automatically providing a consumer with provisioning capabilities as needed. So as per the requirement, the services will be provided. The applications are servers, network and storage. Then the broad network access in the heterogeneous client platforms, which is integrating public and private components from more than one vendor. So the applications are smartphone and tablets. Resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model that is called the resource pooling. The applications are physical and virtual resources with dynamic provisioning. Rapid elasticity is the concept and which is having the capability quickly to meet the demand, the customer demand. The customer benefit from elasticity because they expand or reduce the resources as per their wish. Generally, insurance and e-commerce based applications will use this kind of rapid elasticity. Quality of service, scalability, and elasticity. The quality of service is, refers to the approach that manages the data traffic to reduce packet loss, latency, and jitter on the networks. The service, quality of services, delivery of delay in the packet services that will be reduced. Then the quality of services controls and manages network resources by setting priorities for specific types of data on the network. Then QoS can help reduce network congestion by dropping or low priority traffic during period of peak utilization and by using applications. Scalability. The scalability consists of the ability of a system to be responsive as the demand increases over time. So in case of demand increases, we need to increase the size of our system. Furthermore, scalable system must tackle the increasing workload without interrupting the provided service. So once if we are increasing the system size, the increasing workload also will be taken care properly and without interrupting any kind of provided services. So this particular scalability is used to meet the future demands based upon the increasing workload patterns of a given system. So there are certain techniques will be used in the scalability, that is load balancing. The load balancing deals with large process node to small process node to improve the performance. Then the dynamic, which is distributed to all nodes by using the algorithm, the task of load balancing will be shared. The dynamic distributed. Then the dynamic non-distributed, one node or all node, the algorithm takes off load balancing. So these are all the two things. The load balancing is consists of two types: dynamic distributed, dynamic non-distributed. So dynamic distributed, all nodes will takes the task of load balancing. will be shared. The dynamic non-distributed one node or all node takes off load balancing. Elasticity. So the elasticity consists of ability to tackle changes in the workload of a computer system. So the central idea behind scalability is to provide sufficient resources to the computing system to deal the momentary demand. If the workload increases, more resources are released to the system. On the contrary, resources are immediately removed from the system when the workload decreased. That is elasticity. So if the requirement is high, the resources will be increased. If the requirement is less, the system will be reduced. That is elasticity. It's a kind of flexibility. Cloud security. So it is talking about the protect data stored in the cloud computing environment from thefts, deletion, and leakages. So for that, there are certain things which we need to see to it. Identify and access management, securing data in the cloud, securing the operating system, protecting the network layer, managing security monitoring, alerting, audit trial, and incident response. So these are all certain areas in the cloud security which needs to be taken care by very carefully to avoid unnecessary thefts and deletion leakages of the information. Benefits and applications. Cloud computing services, as we know, it is a infrastructure as a service, platform as a service, software as a service. Everything will be provided here. So cloud computing benefits, it's a small businesses include accessible data, automatics, syncing, remote work facilitation, and easy backups that can be done by using the cloud computing services. At the same time, in the modern businesses, it is very flexible and efficient and scalability, security, increased collaboration and reduced cost. Applications. So if you are looking the applications, online data storage, cloud computing allows online storage like data files, images, audios and videos on the cloud data storage. Then the backup and recovery, then the backup and recovery applications, then the big data analysis. The big data will be stored in the cloud infrastructure. Then the testing and development, the e-commerce applications, cloud computing in education, these kind of applications, the cloud computing services and technology will be used. Now AWS cloud security. The customer in this diagram, we can see this Amazon Web Services cloud security. So the customer is responsible for the security in the cloud here, the customer data. So the customer data, platform, application, identify and access management. The operating system, network and firewall configuration. The customer is responsible for security in the cloud. Then the remaining client side data encryption and data integrity authentication, then the server side encryption and the file system and or data, then network traffic protection, encryption integrity identify. This can be taken place by this situation. Then Amazon as a web service. So the Amazon Web Services is responsible for security of the cloud. So what exactly takes place? Let us see. So it takes place the Amazon Web Server Web Services. global infrastructure, different region having different availability of zones, then the different locations that can be takes place in the global infrastructure. Then at the same time, this AWS is responsible for computing and the networking, the storage of data and the storage of data into the database. All these services can be provided by using AWS. Now moving to IoT. So the cloud services are there. So our applications will be used the cloud services, and the services can be connected to Internet of Things devices at home. The various devices at home also will be connected with each other, and we can control by using the cloud services. Then IoT devices at work. So in the hydraulic equipment industries, the automated machines can work by using the cloud services. Then IoT devices in the community. So in a city, how the traffic congestion or maybe self-driving system can be takes place by using the cloud services. That also the concept which is from the cloud services move to the IoT. So all these services and all simply controlled by from in our apps, smartphone apps. Thank you very much. Thank you all.